Okay. So ideally, this is a day one topic, but since this is an important topic with respect to our training, uh, I am actually I just delayed this topic for day two, so that at fresh we can talk about the topic what is important with respect to our training. Okay, rotorcraft operations and aerodynamics. So when rotorcraft word you hear, what does it comes to your mind? What is your thought process around it? What do you think about what is called rotorcraft?
An aircraft with rotors, yes.
Okay, so is helicopter are also rotorcraft?
Yes, it is. They are.
I think
Yes, anything which is the aircraft with rotors, as you said, the definition. Okay, heavier than air, and it is as it rotates the propellers or the blades, it lifts itself using the Newton's third law of motion, that is every action has an equal and opposite reaction. So the basic principle, the rotor, the blades, they are designed with respect to the Bernoulli principles. They follow the Bernoulli principles, and that is how they create that push of the air. So as it rotates on on its axis, the air is pushed down. Since air cannot push the body below, that is the earth, the object to which the rotors are connected, it will lift on its own. Okay, that is what is the mechanism how rotorcraft works. So initially, the rotorcraft, when we talk, it was just a helicopter with one single blade. Okay, if we have a one single blade, what will happen? The helicopter will rotate, but it will rise also, but its body will also start rotating in opposite direction. So to counteract that, the body motion in opposite direction, there is a tail rotor also is connected, so which keeps the body of the helicopter in a direction. Okay, if that tail rotor is not there, it will keep in moving in opposite direction of the rotor also, so which will be a very disaster, or which will not be advisable, not operatively kind of device for us. That's why we have a minimum two rotors are required. So one is the actual rotor which lifts, and one is which stops rotating on its own axis also. So that is the function of the helicopter. But helicopter is being operated by the pilot sitting inside. That's why it is not as a unmanned aircraft. There are now helicopters are getting designed which are completely autonomous, or probably without a pilot, or they will work on it and all that thing. So there are companies which are developing helicopters also now autonomous and all of it. So when we talk about rotorcraft, it is two or more blades or propellers or rotors which propels the aircraft in the air is called rotorcraft. Okay. So let's see the first. I mean, since we are talking about the UAV, unmanned air vehicle or unmanned air system, okay, UAS. The first UAV was launched as a balloon. Okay, so Austrian balloon measuring 5.7 meter in diameter. They created this balloon, and the basket was filled with sandbags as well as explosives. So this was basically attack on the Italian city of Venice with the unmanned balloon loaded with explosive. So what was the mechanism? They will launch the balloon filled with hydrogen or helium. It will rise in the air automatically, and based on the air direction, it will go. And they have a fuse attached to the basket of the body where it will start dropping the explosives on the city as it reaches a particular distance. Okay, that was the mechanism, but this is not a control mechanism, or not a what we say fail proof mechanism. Okay, this was tried in World War II also by Japan to attack the west coast of the America, but neither of the balloons have reached and caused any damage in that. Lot of time those balloons were lost into the Pacific Ocean. So this was not really a successful, but this was the first attempt of using unmanned balloons, okay, or unmanned aerial vehicle kind of, we could say. Okay, the mechanism of propulsion was different, though it was a balloon filled with a helium or hydrogen gas, but this was the first attempt where unmanned aerial vehicle was tried and tested for on its own to function or give the benefit or create some disaster into the enemy camps. So who is the father of drones? Okay, these are some initial slides which talks about or gives you the history about the drones. Okay, so father of drones is Dr. Abraham Karim. Okay, he was born in Baghdad, that is in Israel. Sorry, not Israel, Iraq, and later he moved to Israel in 1951. He was actually aeronautical engineer from Tekon, Israel Institute of Technology. Built his first drone during Yom Kippur War for Israeli Air Force. In 1970, he immigrated to United States, found their leading system Inc. and started manufacturing his first enterprise drone known as Albatross. Okay, so that first drone what he created, its name is Albatross. Later on, this drone was bought by U.S. Defense Army, and it has been renamed now as called as Predator. So this whatever the Predator drone you see, this is actually the first drone made by Dr. Abraham Karim, and that's what he got the name as father of drones. Okay, he was the person who actually developed the first drone, though it was for a military purpose and all, but that is where actually the drone started as a commercial or application of the unmanned air vehicle. So let's see what are the components. So in this topic, we are going to learn the basic drone overview, types of multi-rotor drones, quadcopter anatomy and terminology, then inner electronics of a drone and application. Okay. So what is drone? So drone can be a aerial, a ground, or underwater vehicle without a human pilot on a board. So when we say a definition of a drone, drone can, it's not necessary when we call drone, something which is flying in there. It could be a device on the ground also. It could be a device or a vehicle underwater also. So all these three types of vehicle without a human pilot on board, that means you are not having anybody to control inside that device or inside that vehicle, remotely you are controlling it, that is called as drone. It is also known as, earlier as we said, unmanned aerial vehicle or remotely piloted vehicle. Okay, UAV or RPV. The entire system is known as unmanned aircraft system, that is UAS, or remotely piloted aircraft system, that is RPAS. So not only the drone, but drone, the remote control, the ground control station, even the pilot is part of UAS or RPAS. Okay, so understand the difference between U and V. Okay, when there is a V, we are talking only about the vehicle. When we are adding S to it, it is about the system. System means complete in totality about the system. So that's what again it says. RPAS means RPA plus ground control station. Okay. So how does drone works? Okay, it may be a remote controlled by human operator. That's why we call it as a RPAS. Or it could be fly autonomously with help of onboard computers. So it could be a GCS where we will be actually configuring the plan for its mission or flying activities. And that plan will be uploaded into the drone, and then drone will follow the instructions what is been provided to it, the flight plan or the way layout what we call, or waypoints what we define. Based on that, the drone will fly, perform its activity, and then again, if it is allowed to land after a certain point in time of completion of its project or mission, it will land on its own. That is how drone works. Okay, so there are different types of multi-rotor drones. So we saw about the helicopter. Helicopter, though it is said it is a single rotor, but it is not a single rotor. There is a one main rotor which actually causes the lift, but there is a second tail rotor which controls the central motion around its axis. Okay, so it is a bi rotor, or two rotors are there. Then we have three rotors. Then we have four rotors, which is called as a quadcopter. Then we have a six rotors, which is called hexacopter. Then we have eight rotors, which is called as octacopters. So the more motors you add, the more thrust, more weighing capacity will improve. Okay, so most prominently used is quadcopter or hexacopter. Octacopter is used when you have a payload to carry a very heavy payloads or something like that. In that scenario, we normally go to hectocopter. But maximum drones, what you will see is quadcopter or hexacopters. Either of these two. Hexacopters are predominantly used in agriculture field. So normally, if you see quadcopter is again 4, hexa is 6, octa is 8, like that, 10, 12. So ideally every time you will see the number of rotors will be always in even number. The odd number of rotors is little bit complex, and it is little bit complicated because the stability you will not get it every time. Whenever you have a even number of copters or even number of rotors or motors, you will have a better stability. It is easier to control and easier to manage this kind of rotors, okay, rather than odd number like 3, 5, 7, like that. People have tried doing it, but they were having a difficulty in bringing the stabilization into those kind of rotors. Okay, so we have quadcopter, hexacopter, which is very popular and widely used variants. Okay, so let's see what are the pros. Yesterday we have seen the pros and cons with respect to the fixed wing. Here there are only pros and cons with respect to the multi-rotor drone. So what is the first advantage of the multi-rotor drone is vertical takeoff and landing. This is the most important part. So you don't require a space, a big space to take off or landing. Whatever the space the quadcopter or the multi-rotor drone takes, that space is enough to take off and landing. Second important thing is hovering capability. So it can hover at a particular location, which gives an advantage for monitoring or doing photography or reconnaissance missions, or capturing data about the location, place, human, property, whatever we are trying to do. We will able to capture that data by multi-rotor to be stable on that particular point or that particular location. Again, because multi-rotor doesn't require big space to take off, landing, as well as operations is can be done in a confined spaces. Like I gave example that there were students who had come from a shipping industries where they were using multi-copter or quadcopter for going inside the ship, very very confined space, very small space, where for a human being also to go was very difficult. In those kind of locations, you can send copter and do surveillance, or you can do survey of those locations, whether there is a damage or whether there is some requirement, or to just to make sure that things are proper or not. Like another confined space I could say is that there are copters designed to go inside the windmill wings, okay, or those propellers. It can go inside because they are hollow inside, so they want to check. Or even in the pipes, industrial pipes, chimneys, or very big kind of refinery kind, where there are multiple pipes and all that things, where for human to go and check every corner of the location was difficult. Drone can go to that location and get you the pictures and give you the update on what is the status, okay, of those locations. So operations from a confined space was possible in multi-rotor drones. Now, what are the cons? Limited endurance compared to fixed wing, because we are powering the quadcopter using LiPo or lithium ion batteries. They have a limitation of the battery life. They can last for 10 minutes, 15 minutes, 20 minutes, 30 minutes. Max to max, I think I've seen batteries which can give you up to 60 minutes. Okay, but the more time what you try to increase, your drone will become heavier, because your battery will become heavier. Your battery will become big. Okay, so people are happy like you fly a drone with 15 to 20 minutes of endurance. Okay, they don't want to go for 60 minutes in one go and all the things. So they will always have a multiple batteries. So that's how you fly the drone powered by the batteries. You don't go for more than 20 minutes or 30 minutes. Max to max, I have seen drones being used with 25 to 30 minutes max, not more than that. Okay, so if you have a 20 minutes of endurance, you will have three sets of batteries. You will fly, you do the activity, the drone will land automatically once it reaches the threshold of the battery. You just swap the battery, again continue your mission. Again, you complete your 20 minutes of cycle. The drone will land. You will just swap the battery with the new battery, and you continue that way. So that is more efficient and more easier to manage rather than putting a heavy batteries and all things. Okay. Second con is less chance of recovery in case of motor failure. Let's say, for take example of a quadcopter. Out of quadcopter, 4 motors, one motor fails. So it will try to stabilize on 3 motors, but it's very difficult to manage the quadcopter with 3 motors only. Okay, so that in point, probably it could crash also, or it may become unstable, and then eventually it will go beyond your control. So that's why the recovery is very less chance. If you are very skilled pilot and all things, then you can probably try to land it with the 3 motors and all the things, but it has very less chance in recovery already. There are quadcopters designed with parachute and all the things, but then those are still not very successfully or effective, because a lot of time the parachute get entangled into the propellers, and sometimes it goes upside down and all the things, because motor are also pushing the air down, and the parachute is trying to control or manage to fly and all that thing. So it's become very difficult in this scenario. Then limited speed. So you can see, compared to the fixed wing, the multi-rotor has very limited speed of flying compared to fixed wing. Okay, though they are moving at very high speed, there are a lot of high speed drones are also getting designed, and there are a lot of competition. Like I saw other day a video where they were trying to build a drone which can fly at the same speed as Formula One car. Okay, there was a competition which was held, and I think drone won, which was flying at 350 miles per hours kind of speed. Okay. Second is, because of the principle on which the multi-rotor drone works is basically not about the glide; it is about the push. Okay, so basically it is pushing the air down. So you will see that when it is on the ground, it starts throttling up. It's push the air down and it rises up. But at certain height, let's say when you go up to, so let's say somewhere 10 feet, 20 feet, the drone will not go up very easily, because there is nothing to push down. Okay, so it will try to go up slowly slowly, but it will not able to perform very high altitude long endurance activities. Okay, so it cannot perform. So these type of drones will not. So that's why you will see, for high altitude long endurance, normally we will have a fixed wing kind of aeroplanes, because which can use the Bernoulli principles to lift up in the sky. Okay, so these are some limitations, but not only limitation, you can see the pros, where like vertical takeoff landing, hovering capability, operation in confined space. This makes the multi-rotor or quadcopter very suitable for creating those kind of activities. So depending upon your application, you have to apply what type of drone you want to use, whether you want to use fixed wing, whether you want to use multi-rotor, or whether you want the combination of fixed wing and the multi-rotor, that is your hybrid or VTOL drones. Okay, so let's see now quadcopter anatomy. I hope you would have seen this kind of a drone in picture or in physically also. A lot of people had made this type of, like, this was the drone which can be made by purchasing the components from various websites. There are a lot of websites where you can get these all components. So what are the components of the quadcopter? So this is a famous quadcopter, where normally most of the people who start learning or wanted to make the first quadcopter of their own, people go for this kind of design. So you have, first are propellers, okay, or the blades, propellers. Then you have motor, okay. Then you have airframe, okay, the frame on which you attach the motor and the propeller to it, okay. Then you have something called as electronic speed controller, or we call it as ESC. Okay, you can see here there is a ESC. Then we have something called as flight controller, which is the brain of the drone. Then you have first person camera or FPV camera. You need to know where your drone is flying in case you are flying beyond your visual line of sight. Okay, in that case scenario, you want to have first person video camera, or FPV camera is what we say. Then we have something called as the powerhouse of the drone, which is a battery pack. Okay, then since the drone, see, a lot of people without the landing gear also create makes the drone. Okay, a small, there is some small extension to this arm itself, so you really don't require a separate landing, but there are separate landing gears are also available, or landing struts what we call, that is also available, so it can protect the entire body and the frame when it is landing, because that is the most crucial or physical activity what happens when it lands. So if normally when it is landing, normally it bumps, okay, it little bit, it doesn't lands very smooth. It's all about the skill, the way it has been designed, or how you land the drone smoothly on the ground. So gravity is trying to pull the drone down, and it is counteracting with the rotor motion of the propeller to stay in the air. So we have to very smoothly land the drone. A lot of time we have seen the landing gear gets break. Okay, depending on the type of landing gear what you are using, whether it is a plastic made, or whether it is aluminum pipes, or they are carbon fiber pipes also, or the frames also, or the legs also of the drones. Then you have a camera with a gimbal, okay, for taking your videos or photographs, whatever. Or you may attach a RGB camera. You can put a thermal camera. You can put multispectral, hyperspectral cameras, or lidar also over there. Okay, so depending upon your requirement. So normally the first quadcopter or drone, what you mean, you will normally put a GoPro or RGB camera over there to take the initial footages about the whatever you want to take. Okay. So what we have in anatomy, propellers converts the rotational motion to a thrust. So there are different types of propeller. There are pusher and puller. Okay, pusher means what? Pusher is basically at the behind, and puller means in front. So whatever normally you have propellers which are attached in the front side, they are all pullers. Okay, if you have in the back side, it is pusher. Okay, so we have observed that lot of time puller is little bit difficult and it creates a lot of pressure on the body, whereas pushers are very simple because you are just applying the pressure on it. So but again, depending upon the application and need and how you design your drone, you can define. There are drones where you have two motors configured as a puller, two motors configured as pusher, or there are all motors configured as pusher or all motors configured as puller. So it depending upon how way you design your drone. The propeller dynamics can be modeled by Bernoulli principle and Newton's third law. So if you see the cross sectional of the propeller, it is exactly like a airfoil section of the wing. Okay, so this is something like a wing itself. Okay, you can see the design. So it will have a leading edge and the trailing edge. So there are two types of propellers. One is pusher and puller, but also the there are called as clockwise and counterclockwise. So if you look at the propellers, you should able to identify the propeller type, whether it is a clockwise or counterclockwise, looking at the propeller itself. So whatever direction you have, okay, the leading edge, you should first identify the leading edge. So whatever the leading edge is your direction of the propeller, the motion of the propeller. So it will always move into that direction. The leading edge will be going first in the front. So if you see this particular propeller is clockwise propeller. Okay, so it will move like this, like this. You're getting it? So this is how your motor, the propeller will move. Whereas if you see this one, this is anti-clockwise. So this will move like this. Okay. So the leading edge will cut the air and the trailing edge will connect the air back. So that is how the vortex is created, or air is been pushed downward. Okay. And then the lift is generated on the propeller. So every motor and the propeller will generate its own lift. That is what we called as thrust. Okay, so for example, each motor and propeller is able to create a thrust of, let's say, 10 kg. So if you have 4 motors with the propellers, so 10 into 4 will be 40 kg of thrust it can create, but will not put a load on that drone of 40 kg. So it is advised when we design, based on the motor capacity and the propeller what we use, whatever the thrust it is going to generate, total thrust what is going to generate, like 6 hai to 6 into 10, that is 60 kg of thrust it will generate. There are 4, then it will be 10 into 4, so that is 40 kg of thrust it will generate. So whatever the thrust we generate, we divide by 2. So that is the actual weight what the drone can pick up. Okay, that is how we design. So if you want to design a drone of 24 kg or 25 kg, within 25 kg limit, we have to design a drone with a capacity of 50 kg of thrust. Okay, that is how we design our drone. So whatever the drone, when I'm saying small class, though it is said so small class and it can take up the weight of 25 kg, it has a capacity to pick up the weight of 50 kg also. But to be optimal use, to have a better efficiency when it is flying, we always consider 50% of its capacity. Yeah, Parag.
Just want to know the example that in this example that you have taken, where you have mentioned that the capacity of each rotor is a virtue of 10 kg multiplier.
Hmm.
Is it a standard rule or is it just an example?
Example. It depends upon motor to motor and propeller what you use. So when you have to see the specification of the motor. Okay, how much thrust it is. See here it is motor speed, thrust value, compatible AC, compatible battery. Every motor will have a specification what propeller you can connect to that motor. Okay, so when motors are been designed in the factory, they are designed with all these parameters. Okay, so the engineers who design the motors, they will specify those things. Okay, and then based on that, you can't use like I have a motor, okay, which has a thrust of let's say 6 newtons or 6 kga. For understanding purpose, I'm taking these numbers. Okay, you have
Okay.
to see actually when you are seeing the motor. So let's say 6 kg of weight capacity hai, or when it will generate a 6 kg means that it has to have 18 inch of propeller. Now that propeller, 18-inch propeller, and that motor will give you 6 kg of thrust. Example, you cannot say that okay, अभी 18 इंच का propeller लगा है तो मैं 20 इंच का लगाता हूँ या 24 इंच का. It will not give you the thrust, okay, or it may not function as it is. So they have been fine tuned or designed for that particular function, because again the rotation, the motor speed at what it rotates at that. So all these components is goes into the designing of the motor and the propeller. So you have to use those sets. So when you go for a purchase of a motor, you have to see what is the compatible or what kind of propellers I can connect. So the propeller also has something called as pitch, the angle on which the blades are being rotated. Okay, the turn. There is a turn or the pitch, what we call. So we have to see all these parameters as a designer, as a of a drone. So you have to match all these values. Then only it will give you optimal performance. Also for specific motors, the specific EACs has to be used. Okay, so like 80 watt, 80 एम्पियर का अगर कैपेसिटी है मोटर का, then you have to use 100 एम्पियर का AC. Your AC should be always little bit higher value than the motor value. Okay, so that आपका मोटर नहीं जलता है या AC नहीं जल जाता है, because of when it is starting or when it is rotating at full speed, it is drawing much of the power, the ampere, the heating capacity increases. So just to counteract or to safeguard, we normally take the EAC also of higher value. जैसे for example मेरा मोटर 25 एम्पियर का है, so I will normally use 40 ampere ka EACs. So higher value of EACs I will. So these are the parameters what we need to use when we are designing the drone. Yes, Parag.
Yeah, the ESC is sorry. What is the expanded form of ESC? Would be
Electronic speed controller. So it's like a regulator.
Okay, so you have
Yeah.
basically it's like a fan regulator.
Fan regulator, yes. But it is control electronic. You are not changing
I'm
any
just
knob and thing,
crude
but there is
example,
a signal provided by the flight controller, which gives the precise signal, and based on that signal, it will vary the speed. That's why it is
Yeah.
called as electronic speed controller.
Speed control. Okay.
Okay.
Yeah.
So I was talking about the example, like when we take a motor, it is creating a thrust of 6 kg. So 4 into 6 will give you 24 kg. So your optimal performance of that drone will happen at half of the thrust. So that is 12 kg. You have to consider 12 kg. Okay, that is what worldwide people follow as a rule. Yeah, Parag. Parag, you
No,
have a question?
yeah, no, I just said I just wanted to check about this. When you say it is like a thumb rule to be on
Yes.
safe side.
Yes.
Whatever is the half would be the take up capacity of that particular drone
Correct.
is a standard rule.
Yeah, that is what is followed actually, worldwide.
Okay.
Okay, whenever we design drones with the BLDC motors. Okay, for the internal combustion, it is altogether a different concept in good. It goes as per the principle, because internal combustion will be mostly being used for fixed wing aeroplanes. Yeah, Jagjit.
So can you explain again how do you identify whether this the type of a propeller, whether it is
Okay,
clockwise
so
or
let me give an example. Like you are designing a drone, okay, and you see whatever normally the thrust value of the motor is given. Okay, so thrust value of the motor would be given in newtons. Okay, so normally just think don't go into the complication of the units. Think Newton means it is basically how much capacity it can take up. Okay, so basically let's say the thrust value could be that motor can be able to pick up, let's say 6 kg of weight or 8 kg of weight or 10 kg of weight. For calculation purposes, I'm taking a simple numbers. Okay, let's say a motor which is having a capacity which can take up the weight of 10 kg. Now when you choose that motor, okay, I want to design a quadcopter Okay, if I take this motor, so 10 kg capacity hai, so 10 into 4 will be capacity will be 40 kg. Okay, so 40 kg is the maximum when it is rotating at the maximum speed and maximum weight it can pick up is 40 kg. But we'll never overload the drone up to 40 kg. We'll always load the drone of half the capacity, 50%. So 40 kg hai, so my drone should be planned or designed in such a way that its total weight with the payload and everything should be around 20 kg. Now, once I zero down on my motor, with respect to that motor, there will be specification sheet which will talk about what all the compatible propellers are available. What are the size of the propeller I can attach to this motor? So there they could say that it could be a 12-inch motor, it could be 18-inch motor, 18-inch propeller, or it could be 22-inch propellers, it could be 24 propellers, 24-inch also. But there are propellers available in different sizes also. That doesn't mean that you can use anything what you want, whatever is specified in the specification document of that particular motor, because those are been tested by the OEM and then they certified that this motor will support 18-inch of propeller or 22-inch of propeller or 24-inch of propeller. Only those propeller you have to use on those motor. Simultaneously, for this particular motor, there will be a value defined for what ACs you can use. Okay, so this motor is having a capacity of, let's say, 25 amperes. So normally you will say 25 amperes means you will always load or use the AC which is higher capacity, 25 se zyada, maybe 30 ampere EAC you will use or 35 ampere EAC. So little bit higher value you will use. So even your motor is drawing 100% of power, your AC will not burn. Okay, so AC will have that 5% of buffer. Okay, so it can draw up to 30 amperes because motor is able to take up only up to 30 amperes. Okay, just give me a 2 minutes. I'm getting a call. Okay, so got it? What I'm trying to say. So, based on first component is the motor. Okay, that is what the defining factor of the drone first. So once you decide on what motor to use based on its specification about the weight capacity, based on that you will design whether you are designing a quadcopter or hexacopter. Okay, if like even octocopter also, a lot of time octocopters are designed in a quad format also. So you have two motors up and down side. So that's why you double the thrust. So each motor will add 10 plus 10, 20. Okay, and 20 into 4. So that is 80 kg of weight it can pull. Now 80 kg it can pull. So you will divide it by half or divide by 2. So you will make it as 40. So my capacity of that drone is 40 kg. So in that scenario, I can design my payload in such a way that it can pick up, including the drone weight, up to 40 kg. That is how I should design. Okay. Once I know my motor is capable of 10 kg of weight, accordingly, I will see what are the compatible propellers are required for it. So those propellers I will use. So by using 18-inch propeller, what is efficient? So there are graphs and techniques given based on the performance, efficiency, and all that thing. So you can study. So as a designer, you can study and you decide what is. Again, it depends upon how far you are keeping the propellers. All this goes into designing part. Okay, and how you are like we have seen there are nowadays the motors are been given a tilt of 5 degree, okay, with respect to each other. So that is how we have seen that the drone is performing more efficiently than comparing the straight or plain horizontal motors. Okay, so this new concept has come up. That's why you see a lot of drones which have been designed by DJI. uh, the motors are little bit tilted into them. Okay, so that tilt of 5 degree gives you more better performance than straight motors on the drones. Okay, this is what is the new study has come up, and every time you will come up with a new way of doing things. So that's how you design the drone. So you start with motor, propeller, then ESC. Okay, rest of other things are just passive devices like the body which house your electronics, or under the body you have a compartment for battery, or you have a connector where you will connect your gimbal and your payload like camera or thermal. camera, or hyperspectral, multispectral, lidar, or sometimes even different types of payloads, like it could be a tank. If you are designing agriculture drone, so you will have a tank with a motor pump, or you may put up searchlight, search and rescue kind of drones which are been designed, which has a camera as well as a big searchlight is been put on it. Or there could be what we call speaker also, like you want to make announcement. So a lot of time you will see the drone flown in Mahakumbh time by IG drones. They have put the speakers on the PA system on the drone itself, so that you can sitting in your control station, you can make the announcement and your drone will fly at that particular location. That's how you will instruct or give instructions to the crowd sitting remotely. Like this kind of application we have seen during the pandemic or COVID times also, like law enforcement people have used drones with the speakers to make the announcement to stay people inside their houses and all the things, or don't form a big crowd or something like that, right? So electronics.
Got it. Sir, an addition question to that is the movement of the propeller, like clockwise or anti-clockwise, does it impact the efficiency of the drone?
Yes, so the way you connect the propellers, I will come to that topic later, because that's a later slides you have something on that topic. So you will have, like in quadcopter, you will have two propellers which are clockwise and two propellers in anti-clockwise in diagonal position. So practically also, when we go for doing practicals, that time I will also explain in more detail and you will see them practically also. Okay.
Sure, sir.
So I'll let you know that point in time, because I want you to see them physically. Because I just say that yeah, clockwise and anti-clockwise, as I said in the earlier diagram, it may not made sense to you. Okay, but until unless you physically see them, okay, even the motors are designed clockwise and counterclockwise. So when you are putting a propeller, or you're changing the propeller, or you're making the drone, you need to see that if you're using a clockwise propeller, your motor also has to be a clockwise. If you are using an anti-clockwise propeller, your motor also has to have a anti-clockwise combination of it. You can't use vice versa and all that thing. Okay? So you have to see what motor is there, accordingly that particular motor has to be. Okay, so practically when we do it physically, when we see the drone, that point in time we'll see these things in more detail. Okay, so when I am briefing you about the drone, the first topic on the practical session is about the briefing. Okay, so that briefing session will cover all these topics. So now electronic speed controller used to vary the motor speed with precision, can control the direction of the rotation of the motor. Even using the AC, we can change the direction of the motor. But in bigger motors or bigger drones, you do not do those things. Okay, there are motors which are designed for the direction. So your motor has to move into that direction. If it is supposed to be a clockwise, it has to be move in a clockwise direction. By swapping the cables into the AC, you can change the direction, but that is not advisable in bigger drones or bigger motors. There are motors which are very small and cheap quality. In those type of motors you can do all these things, but in a bigger or complex motors, where because they are the magnets, what are they are been designed, or they have been oriented in a way they should function as a clockwise or counterclockwise. Yes, Jaising.
So I have a very basic question. Is quadcopter the most common type of drone that is used?
Yes, I
Okay.
would say if you say 100% of drones are flying, out of that 90% are your what we called as uh,
Quadcopter.
quadcopters, and 10% are hexacopters. So hexacopters are mostly used in agriculture only. Okay, predominantly
Okay.
you will see maximums are quadcopters.
So
Okay,
that is basically the most general type of drones.
stable, yes, stable and general basically. Okay, and easier to see. By adding two more propeller is just you are adding the power,
Power. Correct.
right? जैसे हमें फोर व्हील्स है हमारे कार को, राइट? बाय
Hmm.
एडिंग मोर व्हील्स व्हाट हैज हैपन, इट गिव्स द पावर.
Yeah.
ओके, इट कैन हैव अ वेट टू रेशियो. लाइक बड़ा बड़ा ट्रक्स में मल्टी एक्सेल जो होता है, व्हाट इज दैट डूइंग? इट इज नॉट, इंजन इज नॉट पावरिंग द एवरी व्हील एक्चुअली. इफ यू सी, it is only the two wheels or maximum four wheels have been powered by the engine, but rest are other wheels are only to get the manage the weight part, okay, or smoothness of it. जैसे heavy vehicles रहता है उसमें you have a multi axle. Those multi axle are not adding any power to the truck or the vehicle. Okay, it is only managing the weight,
Distributing the weight. Yeah.
distributing the weight, I would say. Okay, so
Then,
quadcopter is the most famously used drones. Okay,
got it.
so electronic speed controller used to vary the motor speed with precision. So it can give you exact the moment you give this, pitch forward, pitch back, roll left, or throttle up, throttle down, whatever commands you give from the RC, that is been taken by your flight controller and converted signal is sent to the ESC, and accordingly ESC will control the speed of the motor. Right. So that is the use of electronic speed controller. Yes, Jagjit.
Sir, another question. Sir, when you say there are 4 or more motors, is there a fail-safe mechanism here where if a particular motor fails, like how it's there in an airplane, the airplane still functions. May
Drone you do
not
not have. Drone you
you
do
don't
not
have.
have.
So even if one motor fails, then
It will become unstable. It's all
okay,
up to the pilot skill whether he in that time frame whether he is able to somehow land
land
the
or not.
drone with
Okay,
minimum damage. Okay, or it
okay,
will 100% damage. I mean, it will crash. So there are chord formation octocopter. Okay, where you have two motors up and down connected. In that scenario, you can still manage some. So it just add some kind of a stability, but not 100% stability. Okay, so as I said, the multi-rotor drones are not aerodynamically designed, so it will fall. Eventually, it will fall after certain period of time. Okay, if whatever time you have in that time, if you are able to bring it down very close to the ground and at least minimum damage के साथ आप उसको land कर सकते हो, but not 100% safe.
okay. So there is a concept of safety net also that I seen that has come out. So
बट
does
आपका
that
ड्रोन
work?
सपोज हाँ सेफ्टी नेट है बट वो कहाँ पे रहेगा आप सेफ्टी नेट तो उसके नीचे जाएगा नहीं ना इट विल ओनली
Right.
लैंडिंग के टाइम पे सेफ्टी नेट हो सकता है
Hmm.
there are drones like yesterday I showed you on the digital sky platform the second drone which is called made by crystal ball okay that drone is having some mechanism called as parachute okay but lot of people have purchased but they have tested it but it was not really 100% successful क्योंकि लॉट ऑफ टाइम क्या होता है ना पैराशूट वो प्रोपेलर के बीच में अटक जाता है वो प्रोपेलर पैराशूट को ही पुल डाउन कर देता है so it get entangled between all the things so it's not 100% successful of recovery mechanism there are different recovery mechanisms this is zipline जैसे है या फिर safety nets है but those will be only at particular location when your drone is in your control बट आप यहाँ पे बोल रहे हो कि मेरा एक मोटर फेलियर हो गया वो मोटर फेलियर कहीं पे भी हो सकता है वहां पे नेट नहीं होगा तो इवेंचुअली इट विल क्रैश ओनली ना
Correct, correct. Got it.
ओके नाउ दिस ESC आल्सो हेल्प अस टू मेक अ डायनामिक ब्रेक मतलब आपने देखा रहेगा ड्रोन जब लैंड होता है ओके इट लैंड्स एंड मोटर्स आर बीन स्टॉप्ड इमीडिएटली okay so that is something what we call it as arming or disarming the motors okay so that is done by the dynamic brakes then also these ESCs also have some additional cables connect where it can power the flight controllers or receivers also because it is drawing a raw power you see this red and black wires on the ESC these are the raw power connections so these are directly connected to the battery so it is taking a power from the battery and then there is an electronic circuit inside the ESC the three wires what you see here they are connected to the motor but there are additional cables which can connect give the signals to the or take the signal from the flight controller also or from the receiver also so that's how you have the ESCs so you see there's 40 A's written okay you will see this number the prominent number written on the ESC will be like this 25A 30A 35A 40A 60A 65A 80A 85A 100A these type of numbers you will see so that is the capacity of this particular ESC to draw the current from the battery okay so maximum it can draw a current is 40 amperes so in this scenario I can use a motor with less than this number so I can use 35 ampere motor 30 ampere motor 25 ampere motor 20 ampere motor whatever it is okay so whatever number you have specified on ESC less than that ampere we can use as a motor Or you see from other perspective, whatever the motor has rating of amperes, you use always ampere on the AC of higher capacity. अगर मोटर पे 25 है तो go for 30 ampere AC or 35 ampere AC. Okay, that's how you will safeguard your AC, because here you are getting a raw power. Your motor is drawing the power. Okay, so it will try to get as much as power when it is at 100% throttle or 100% speed efficiency. So that time it is drawing 25 amperes. तो 25 amperes के ऊपर 25 एम्पियर का एसी लगाओगे तो क्या होगा, वो गर्म हो जाएगा. या उससे कम वाला लाइक 20 amperes का लगाओ तो क्या होगा, it will fully load the AC. The chances of your AC getting on fire और burn out होने का chances तभी है. So to safeguard your AC, you will always use higher capacity of AC. Clear on this concept? What AC to be used along with the motor as well as the propellers? Okay, so now
Yes.
the flight controller or the autopilot what we use is the brain of the unmanned aircraft system. It helps in flight stabilization, navigation, and fail-safe redundancy. So this flight controller, the prominent or the most famous flight controller is Pixhawk by Ardu Pilot. Okay, so Ardu Pilot is the #1 flight controller in the world, widely used. So all the variants of the flight controller what you see are derived from this Pixhawk. जैसे हमारा कंप्यूटर्स में ब्रेन क्या है, सीपीयू. हु मेक्स द सीपीयू?
It used to be Pentium Intel.
Intel. So Intel is the company, the Pentium chip जो आया था. Okay, and then the variant has been developed by Intel. But whatever the technology you saw in the Intel has been taken by different companies like AMD हो सकता है.
Correct.
You know, they have changed little bit architecture and all this. Later on, they have redesigned all the things. But eventually, the idea is taken by from the Intel chips. Okay, so same thing in the flight controller is the Pixhawk by Ardu Pilot. Okay, so that is the famously used flight controller. Okay, so initially, if you design any drone, people will start using either Pixhawk or there is a separate APM from Ardu Pilot also is there. Okay, so there are two types of flight control. So there are variants of this. Then DJI has taken the concept of Pixhawk and they have designed their own flight controller. Then you have lot of customized people have created lot of variants after studying the Pixhawk flight controllers. Okay, even you can design your own flight controller by using microcontrollers also. Okay, by purchasing a microcontroller like Arduino, Raspberry Pi, Mango Pi, or and then you have a lot of other components like sensors, IMU sensors are there, or accelerometers are there, magnetometers are there. All these sensors you can purchase them separate, or you can get a modules also which are there, and you can create your own controller also. Okay, but then you have to be a very efficient designer, engineer, electronics person with the coder, all that things you need to know. So it is very fun when you trying to design your own drone with all these components. It's a good learning experience. So you will see lot of engineering students, those who are in computers, electronics, mechanical, they go for designing aeroplanes or designing drones. Okay, because there you will learn all aspects of the science and technology and electronics and coding and everything. So in totality, when you are into this kind of field, you will learn everything. So it will be like a multidisciplinary learning for you. Okay. So any questions on flight controller? Okay. Then we talk about the frames. So UAV airframe consists of housing enclosing the electronics, motors, boom arms, and platforms. Okay, there are different configuration of quadcopter. It could be H shaped. Okay, this is H shape. Then X. Okay, or plus shape. Okay, you can see here plus shape. Or again H in hybrid. So you can see these are little bit twisted. Okay, so based on the position of the propeller, the efficiency has been designed. So you will see normally for the speed purposes, okay, you will see this kind of codex or codex or frame, or there is little bit angle given to the arms, okay, to add the efficiency of the flying. Especially in FPV drones, you will see this kind of configuration. Okay? In a normal drone for normal regular performance, or where you are not concerned about the speed or aerodynamics, you will see either plus shape or H shape or X shape kind of configuration. But in FPV, you will see is little bit twisted configuration or angle configuration in their arms. Okay, so that's the airframe. To power that entire drone, now you have propeller, motor, you have electronic speed controller, flight controller, and your airframe. You make the drone. You need to power the drone. It has to give the power. So you will use power plant for UAV. What is the power plant for UAV? Is battery pack. Okay, so battery pack comes in the two types. Either it could be LiPo or lithium ion, which are widely used as they are rechargeable batteries. High energy density compared to conventional battery. Like normally we use those cells, double A cells or triple A cells. Compared to that, they are high energy density than conventional batteries. They vary by the number like discharge rate, capacity, or voltage. Okay, so normally we'll always see the battery with respect to the capacity. हम लोग मोबाइल में देखते हैं ना 1000 mAh की बैटरी है 2000 mAh की बैटरी है nowadays you are getting a mobile with 5000 mAh or even 8000 6000 8000 10000 mAh की battery. The more power it has or more capacity has, the longer your mobile will be there. The same goes for the battery in the drone also. The 5000 mAh is giving you 10 minutes, 10,000 mAh will give you probably 18 to 20 minutes, right? Yeah, Jaishil.
Sir, I just wanted to ask. So you mentioned FPV drones, right? Vis-a-vis in the shape and aerodynamics to common drones. What is the difference between an FPV first-person view and a normal drone in terms of usage or aerodynamics? Because you said
So, so
normal
for
drones are simple.
example, FPV drones are basically first person view means you have a camera on it and you are seeing it as you are flying the drone. It is inside the drone. You will put a goggle can you fly? Basically, these are used for competitions and all the things. Or you want to actually monitor certain location or something like for example, military का कोई mission है. Okay,
Ah,
जैसे आप attack, you are trying to get into the enemy camp and you want to see yourself what is what and position. So you will put a FPV camera on the mobile, sorry, on the drone, and you will wear the goggle and you will see. Or you may project that on your screen also, so that all people can see what drone is trying to see over there. So those are FPV drones. Okay, and they have a very high speed. Okay, very high speed. So you are very difficult to catch them or hold them or this thing. So at a very high speed you will able to do all your activities. Normal drones are like your agriculture drone, surveillance drone, monitoring drones, where you may not be using FPV camera. It might have FPV camera for your purpose, but the purpose of those drones are for different purposes. Like you are taking a photograph, you are doing surveillance, you are doing crop monitoring kind of things. So all that is your other
so it
configuration
will
of
still have a camera, no, sir? Even,
still it will have the FPV. Even our agriculture drone has a FPV camera on it.
but its primary feature will not be FPV.
Yeah. So primary feature or primary usage is not to do fly it as FPV. Okay, you can use like मैं spray कर रहा हूँ and I want to see मेरा crop कहाँ कहाँ पे spray हो रहा है मुझे देखना है तो I will wear the goggle and see it if I want to do it. But वो आपको initially मजा आएगा लेकिन over the period आप समझो दिन में 10-15 एकड़ कर रहे हो तो you will not wear the goggle आपको headache हो जाएगा, right? So it is only need basis you can use it. FPV is the word basically for those competition. जो FPV के competitions होते हैं ना drone competitions करते हैं वहां पे where the person wears the goggle and flies the drone. So he is actually seeing the drone as he is inside the drone and flying it. Okay, so he is actually seeing the obstacles and flying. So that's where you need
Basically,
everything.
virtual reality, right? As
Yeah,
you
it's like a virtual reality, but it's not virtually creating. It is actually giving you the footage what drone is where
real time access.
real time view, real time view.
Got it. Clear.
The battery pack we are talking about, so capacity is the most important. 5000 mAh की battery है, so it can give you up to 10 minutes of or 12 minutes of flying time. Not necessary by doubling this capacity we'll get the double the endurance because 5000 mAh की battery suppose 500 grams weigh कर रही है. 10,000 mAh की battery will weigh you somewhere around 800 grams or maybe 1000 grams. So you are adding a weight. So that weight will compromise of your flight time also. So not necessary agar 5000 mAh is giving you 10 minutes, 10,000 will give you 20 minutes. It may only give you up to 18 minutes because that weight is added. So that weight is you have to compromise on the flight time over there. Got it? And you have, yeah, Parag.
Uh, about the last part on the battery section,
Hmm.
you mentioned that the more batteries you add, it adds weight, which is practical. But if the usage of that drone is not to for movement for a longer duration or longer or what do you call a expansive space being controlled, but for a shorter period, but requires a longer period of observation, then in that case, this the higher battery usage can be advisable
Yeah, yeah.
or
So
not.
it depends upon what is your purpose. So I am only
Okay.
saying here is by 5,000 10 minutes there hai, so 10,000 will not give you 20 minutes. You will get little bit less. So अगर आपका requirement 15 minutes का है तो आप 10,000 mAh का use कर सकते हो.
Say
Rather
for
having
example,
rather having two cycle of 5,000, you in one cycle only by adding that battery you can complete your mission.
that is exactly what I wanted to know, whether it is standard rule uh, which does not hinder the operations by increasing the number of battery because the usage is for a particular specific purpose.
Correct.
Then in that case, these alterations can be possible on the drone in a normal
So
scenario.
when you are designing a drone, that all this comes into the picture. For example, मैंने एक agriculture drone design किया, okay, and I see that my battery, whatever I am putting, let's say take an example, I am putting a 20,000 mAh battery, 21,000 mAh की battery लगा रहा हूँ. Okay, by that 21,000 battery, I am getting a flight time of 20 minutes. Okay, and within the efficiency of my drone, whatever design, in 15 minutes, I am able to cover 1 acre of land. Okay, with 10 liter of tank. तो ये सब क्या है ना ऑप्टिमली मैंने डिजाइन किया है. नाउ देयर बाय एडिंग लेट्स से 30,000 mAh of battery, I may go to 30 minutes of flight time. बट दो यूज बिकॉज मेरा 30 मिनट्स डालने से 10 लीटर टैंक तो मेरा एम्प्टी हो रहा है 1 एकड़ में ही. तो मुझे
Right.
एंड ऑफ द डे अगेन आई हैव टू ब्रिंग द ड्रोन डाउन अगेन फिल इट बैक ऑल दैट. सो इट इज नॉट यूजफुल फॉर मी टू पुट अ 30,000 mAh बैटरी. मेरा
No, no
21.
sorry, not in that case. But if, for example, if I'm using the drone for mapping purpose, there is no tank required. It is purely surveyor. So in that case, the addition of additional ampere batteries will give will be able to help me complete the work in a shorter period of time because it doesn't cover. It does not have to go further off, nor it has to carry more weight.
Correct. So in that scenario, if you're taking about surveillance, if I see I design a drone, okay, which can fly for 20 minutes, okay, and in 20 minutes I'm able to cover 10 acre of land in mapping, okay, I am happy with that. By adding more battery to it, I see that I can cover more area, but whether that is my real requirement or not, and whether I can add a battery or not, because you can't change the battery also a lot of time. Okay, the drones where the compartments of the battery, like if you see in DJI, okay, you can't change the batteries or you can't add batteries as you wish. Okay, whatever the battery set they have designed for that particular drone, they have been designed for that function only. Like for example, Air 3S, okay, DJI का Air 3S drone है, okay, which has a flight time of somewhere around 25 minutes. And so if you want to have more area to be covered, what you will do is they have now started. Initially there was only one battery provided by the DJI. Now they have changed the concept. They have built a battery pack which has three batteries in itself. Okay, so you can put three batteries in one charger. You connect one battery, you fly, the drone will fly and perform the action. It will come back, you change the battery, it will resume further on the second battery. Again, it will come back, you again add the third battery, again it will resume from where it. So that's how you use, rather making your drone heavy and because जितना बड़ा बैटरी है उसको उतना बड़ा कंपार्टमेंट उतना उसका efficiency, all that things will add complexity in designing. So somewhere you need to create a base variant of it. Okay, by just adding battery will not help you to have a better or efficient drone.
Okay,
Okay,
one small.
but that will not add efficiency to your drone.
Okay, I don't know whether I'm digressing, but just wanted to know now. Import of drones are illegal as of now in India. But I remember yesterday you had said that people do buy components and assemble and make it here. Do
Right.
we have in India OEMs who manufacture components of drones in India or no?
Yes, so we have OEMs or startups which have started manufacturing their own motors, propellers, EACs, okay, batteries, all this. Even the frames, you can get carbon tubes, carbon sheets, everything you get it. So you can really make your own drone, except flight controller. There are startups which have designed customized flight controllers also. There is a company in Nasik called PDRL. They have come up with their own flight controller also. Okay, so there are companies which have already started manufacturing components, but not 100%. Okay, again, if you see the semiconductor, like EAC हम लोग बना रहे हैं, मोटर बना रहे हैं, everything we are making it. Like for the magnets, magnet के लिए जो material लगता है वो इंडिया में available नहीं. We have to import it from China or Japan kind of location, okay, or maybe South Africa or South America location. So जो magnet, जो neodymium magnets लगता है वो इंडिया में नहीं है available, so you have to import. So that's not 100% made in India kind of thing. There are some components which have been brought from outside, but yes, around 60 to 70% components are now available in India to make your own drone.
So in that case, when I
Earlier,
make
yeah,
sorry, so if I assume that I am able to create a drone from by myself, okay,
Hmm, hmm.
and will this drone I can register with on the DJI platform, passing going through all the procedures, or it has to pass through the manufacturing route. Say I become a manufacturer, then in that case, which what kind of where will I be classified under?
Okay, so there are two aspects to this. One is you are making a drone, whether that drone what you made is for yourself, okay, or you want to become a manufacturer. Okay, if you want to make your own drone for your own purposes only, as a hobby or learning or whatever it is, you can make these drones and you can get it registered also. Okay, that is one thing. It will be a OEM, but a non-type certified drone. That is
Okay,
one. Second, you want to go for a manufacturing. So you want to go for a manufacturing. Go for the manufacturing means you build again a prototype. Okay, you do all sorts of documentation, reporting, lab testing, all that aspects you have to do it, and then go for type certification. Once you have been awarded a type certificate, you can go for manufacturing of this drone and selling this drone in India.
okay,
I hope you answered your both
yeah,
aspects.
yes,
Yeah.
yes,
One
yes,
is the hobby part and learning part. One is the OEM part of the manufacturing part. So both you can
got
do. Both you can do. But here the catch is only the components. You will not able to make 100% made in India kind of phone. Like flight controller pe aap still you will have some challenge. Like even I said, ki PDRL is making their own flight controller. But I do not know the components what goes into the PDRL फ्लाइट कंट्रोलर आर मेड इन इंडिया और नॉट. जैसे कि उसका सेमीकंडक्टर चिप है या फिर उसका मदरबोर्ड है, जैसे पीसीबीज है, वो भी चाइना से बन के आके यहाँ पे ये लोग सिर्फ असेंबल कर रहे होंगे. आई एम नॉट अवेयर ऑफ इट. दे आर
okay,
सेलिंग इट एज देयर ओन फ्लाइट कंट्रोलर. 19,000 रुपीज का फ्लाइट कंट्रोलर है वो. ओके, in between they had some discount offer which was they were selling for 12,000 rupees. So that was there, but I'm not really 100% sure whether that entire flight controller, the components what goes inside that front flight controller are made in India. Like for
okay,
example, अगर हम देखें motherboard, chips, computers में भी अगर आप देखोगे parts, you know, lot of parts are been made in Taiwan, lot of parts are been made in China. So even though we say made in US, you know, the laptop or whatever it is, they are not really made in US. There are a lot of components which are made at different location and different parts. जैसे अपना iPhone, हम क्या सोचते थे एप्पल आईफोन हो, यूएस का आईफोन है, बट अभी पता चला उसका कंपोनेंट्स तो सब चाइना में बनता है, right? So
right,
that is how it is go. That is how the ecosystem. You cannot make everything on. That may take little bit longer time and you know. So there are some components which are made in India. There are some components which we are like battery. तो हम लोग बैटरी इंडिया में बना रहे, बट द सेल जो अंदर का है या अंदर का कंपोनेंट लिथियम है, वो सब चाइना से आता है,
got
राइट?
it.
So that's why we say it is not 100% indigenous made in India. Okay, so we
Got it.
normally certify it as 60-70% it is. So yeah,
Got it.
actually I don't see this. This is, I mean, see, you can't, any company or any OEM cannot make it everything on their own. They are always dependent on some other people. Okay,
Got it.
ऐसा नेसेसरी नहीं है. फॉर एग्जांपल आप कोई प्रोडक्ट बना रहे हो, वो पैकेजिंग आप नहीं बनाओगे ना. पैकेजिंग के लिए आप कोई और, जिसका जो कैपेसिटी या जिसका जो कैपेबिलिटी है वो उसके पास से आप बनाओगे. आपकी कैपेबिलिटी है चिप बनाने का, तो आप चिप बनाओगे, बट वो चिप का पैकेजिंग करने के लिए आप पैकेजिंग का जो माहिर है उसके पास जाओगे, राइट. या फिर जैसे
Absolutely.
फॉर एग्जांपल आईफोन है, आईफोन का कैपेबिलिटी था टू डिजाइन द आईफोन, बट उसका जो गोरिल्ला ग्लास है उसके लिए दे हैव आउटसोर्स इट टू अ डिफरेंट कंपनी टू मेक द ग्लासेस फॉर देम. सब कुछ वो खुद ही नहीं बना सकता है ना. नो कंपनी और नो कंपनी कैन मेक इट. देन दैट विल बी अ वेरी बिग इकोसिस्टम यू हैव टू सेट इट अप.
Right.
ओके.
Okay. Thank you.
So camera, so now you have camera and gimbal. So gimbal is basically to add the stabilization, because without gimbal, if you attach a direct camera to the drone, then it will be a fixed frame kind of photographs. Okay, like in surveillance, kabhi use karte. But you want to have a different angles and all that things, and then add stabilization, because drone is moving, drone is creating vibrations and all that. So you have to stabilize photo. Your videos should not be shaky. Your photographs should not be blurry or shaky kind of thing. In that scenario, you will normally use gimbal. So 99%, I would say 99.9%, you will always see camera with the gimbal. Okay, so gimbal basically helps in stabilization. You can have pan control and tilt control also. So both axes, you can move your camera to get the footages. Okay, landing stress. This is the important part. These are the legs that drone rest on when it is landing on the ground. Okay, comes in a different shapes and size and design. UAE can be foldable with the help of servo mechanism, result in better field of view. Like you can see, there are drones like DJI Inspire. In DJI Inspire, your landing gear goes upward direction when it is in flight, so that your gimbal and the camera can rotate in all 360 direction. Okay, so your view is not been obstructed by the landing gear. So there are those kind of landing gears. Some landing gear even has the hydraulic function into it, so that whatever that bumpness what you get into when it is landing, that is also been reduced, so it doesn't transfer to the body of the drone. Or a lot of time we see the cracks or breakage into the landing gear where it connects to the body of the drone. So those are been minimized by using hydraulics into the legs. Okay, then we have radio transmitter and receiver. This is RC. That, as I said yesterday when we were talking about radio telephony topic, the band or the frequency on which is communicated. So RC communicates at 2.5 gigahertz, because this is what it is maximum efficiency you get on this particular frequency when it is communicating. Similarly, your FPV is being communicated, the video transmission is communicated on 5.8 gigahertz. That's why you see in that frequency there were two bands which was taking up your drone communication. So one is your normal communication, the telemetry and your RC communication, which is at 2.4 gigahertz, and video transmission is happening at 5.8 gigahertz. There are separate devices called telemetry devices also connected to the drone as well as to the my ground control station, which captures the crucial telemetry data like altitude, distance, speed, wind speed, and temperature, and all other parameters, right? It can show you the real time motion of your drone on the screen also. Okay, so dynamic updation of flight plans and any changes in the mission can be done using telemetry devices. Okay, so this is about the communication and getting the data from the drone and from your ground control station also. So they are continuously communicating. So when you are flying the drone and the RC, they are always in communication with each other. They are always sent. There is something called as a handshake. Okay, there is a handshake happening between both the device. So this we'll see more in detail when we go a topic on emergency handling. Okay, when there is a loss, like my remote control is not able to communicate to the drone, or my drone is not able to communicate to remote controller. So what happened in that scenario? Okay, or how does drone knows that okay remote controller is not reachable, or remote control knows drone is not reachable. In that scenario, it's a communication loss. So what happens in that scenario? So we'll see in that topic. Okay, or even your ground controller, your telemetry devices are not able to communicate in that scenario. So what should drone do that? Because your drone is out of your control. What you will do then? How you will control the, because drone is in air? क्या करोगे आप फिर उसको? Right? You will be completely in out of control. You can't do anything in that scenario. But there are some fail-safe mechanism are being built into the drone, so that your drone is brought into the control or maybe made it to safely land. Okay. Then you have something called as strobe lights. Okay, you will see a lot of, earlier the drones were not having this kind of communication, but DGCA has made this mandatory, and because they are developing the BVLS guidelines, so they want the drone to be having strobe lights. So you will see a lot of drones with the strobe lights, or they might be having some colored arms or reflective materials being connected. Even on DJI, you will see these lights are there, or there are reflective, or radium kind of radium stickers they have put up, so that you can identify the orientation of the drone. Okay, you when you see the drone, you know what is the front side of the drone, back side of the drone. When you're flying it, after certain time, you lose the orientation of the drone. You do not know which is the front and back of the drone. It becomes very difficult when the very far away from you. Okay, you will not able to identify the front and back. So in that scenario, you should have those lights. Okay, or you have to have some reflective material put on the drone, so that you know which is the front side, back side, and accordingly you can, or maybe the color of the arms. Okay, when you design this type of drone, the two arms are with red color, two arms are with the white color, or combination of the different colors are there. Okay, so these are the indicators. Then we talk about yesterday one component about the is about the uh, broadcast. Okay, about the presence of the drone. So this device is called ADSB, that is automatic dependent surveillance broadcast. This is there in all the civilian airlines or civilian aeroplanes. This will get mandatory once the DGCA makes it mandatory in BVLS condition. Okay, so in BVLS condition, you need to have ADSB component. So this is the red color device. What you see, this is the ADSB device. So this will needs to be connected with the flight controller. It will periodically broadcast its information, so that your drone can be tracked. So it will help to determine the position of a drone using satellite navigation. This is the key for the airspace safety. So when you are flying the drone in possibly in yellow zone, or you have multiple drones flying in the city, in that scenario, every drone needs to know about its own presence as well as the other drone also. So it's like knowing the proximity of the other drones. So you need to have this device put up on your drone. Okay, so real-time ADSB is used now for air traffic controller and flight information services. Yes, Parag.
Is it something like PCAS in
Yes,
airplanes?
yes, yes. Similar to that. So TCAS uses the same concept of ADSB.
Okay.
So basically, it transmits about its presence. It broadcasts about its presence, and that's how your radar detects it, and your all other devices, whatever the ATC are using, they are able to pick up the information about the aeroplane. Okay, there are other controllers, like microcontroller is the brain of the flight controller. So when we see flight controller, this PICSOC, there is a microcontroller, and then there are other components also in it. Okay, but whereas the microcontroller is the brain, it's a real brain which actually computes. Okay, it takes the inputs, gives the output. Everything is been done by the microcontroller. So this microcontroller could be anything. PICSOC has its own chip which acts as a microcontroller. You can use Arduino, you can use Raspberry Pi, you can use Mango Pi, or whatever these small microcontrollers are available. Or even you can use your normal brain, like normal CPUs also, even NVIDIA CPUs, all that thing. But then it will add cost to your controllers. Okay, so there are some already fixed or customized microcontrollers or the flight controllers available for this kind of activities. ओके, सो आप आर्डिनो लेते हो, तो ये सब चीजों का आपको कॉम्बिनेशन करना पड़ेगा, टेस्ट करना पड़ेगा ना. होता है, I mean, lot of engineering student does during initial phase of their career or their phase of learning, they do all these things. But eventually, they go once they are into their jobs and everything based on their company requirements. They will be using the standard flight controllers and all. Yeah, Parag, you have a question?
No, no, I just it's wrongly clicked the sign.
Okay, fine. Okay, so about the microcontroller, so often connected to the ground station through a radio or connected to a pilot through a control link. So it could be the flight controller is always in connected with the remote control or to the ground control station. Okay, the flight controller will give signals to motor via ESC for both sensors and user input. So probably sometimes it is flying on its own. When it is flying in autonomous mode, the flight controller will give the signals based on the flight plan. Sometimes you are giving the signals through your remote control. That remote control signal will be converted by the microcontroller, and then through AC it will go to the motor, and accordingly your motor will perform. Either it has to move fast, slow, low, high, whatever the speed you are intent to fly, accordingly it will fly. Okay, then there are something called attitude and heading reference system, because this will tell, this controller or this sensor will tell the orientation of the drone. Normally this attitude and heading reference system is most of the time either it is in GPS or also it is in the flight controller also. So different devices uses this module also to find the location, okay, or the orientation of the drone. So we talk about the roll, we talk about the pitch and the yaw. So whenever you are doing the roll and yaw, this particular module is sensing the motion. Okay, so it's sensing the motion of the drone, and accordingly it is saving that information, and accordingly it is changing. Okay, so जैसे आपने suppose fly कर रहे हो, आप west side fly कर रहे हो. Okay, so it knows that it is flying in a west direction. So that compass and all these reference systems are there. So you will see there is a component called inertial measurement unit, which has components like accelerometer. It will have a gyroscope. It will have a compass. It will have a magnetometer. So different modules are there in IMU. Okay, inertial measurement unit. So this will give you all the inputs to the flight controller. Okay, so this basically module helps for autonomous flights. It also helps when your GPS failure happens. So in case your GPS module is there, if GPS failure happens, the inertial measurement unit or IMU will help drone to get it into the control. It helps the pilot to bring the drone to the safety and land it safely. Okay, so a lot of time we use drone without even GPS. So using only IMU, I can still control my drone. Okay, GPS is basically helpful when we want to coordinate or fly the drone with help of latitudes and longitudes, or probably map. Okay, so map is basically nothing but it's a position system. So on map you can point, okay, this particular point. So when you're clicking on a particular point, it is taking the latitude and longitude of that particular point on the map, and that is being sent to the drone, and then with the help of GPS it is able to fly with those coordinates or with those points. So when GPS is there, you can, using help of GPS, you can configure return to home, that is RTH, or maybe RTL also. So GPS will be helpful when we have flying the drone under the BVLS conditions. Okay, capture details of the specific location on the land. Okay, so GPS is useful when you are actually flying BVLS conditions. It will also help in the fail-safe mechanism setup also, like return to home, return to launch location kind of things, or even in certain case battery failure also, like your battery आपने 100% charge का, normally it is always advisable to use 100% charge batteries. Okay, in case your battery goes beyond threshold, like I have configured my drone or the OEM has configured our drones for 40% fail safe. So the moment it reaches 40% of battery, my drone will automatically trigger the RTL or RTH. Okay, so automatically 40% क्रॉस हो गया, पहले वार्निंग देगा 45 पे या 50 पे वार्निंग देगा, you are reaching the minimum battery safe fail safe. Okay, by the time you reach 40%, जैसे अपने 40% reach हो गया, automatically the drone will be out of your control and it will trigger RTL or RTH. Then we talk about the power. So as we have a battery, so there is a module which is required, which is called as a power module. So there is a component, a cable So one side of the component of that cable is connected to the battery, and other is end is connected to either to ACs or it is connected to PDB, that is power distribution board. Sometimes you have one cable coming from the battery and other cable coming to the battery from the power module and connect to the power distribution board. So you can see on the right side there is a small PCB which is called as the power distribution board. So you can see the battery connector is connected to the power distribution board, and then you can see four connectors on four sides, right? This will get connected to the EACs, and which will eventually the AC will connect to the four motors. If you have a six motors, then you have to have a PDB with six connectors. Okay, this is only for four quadcopter. Similarly, for six also you have, for eight also you will have a different power distribution boards. Okay, so receives power from the battery, distributes the input to the multiple ESCs, can power even different accessories like attached to the drone, like HD cameras, LED lights, gimbal, all. So there are a lot of connectors on the power distribution board. So power distribution board is the main board where it gives you the power to the other components attached to the drone. Okay, so with that we complete the components of the drone. There are last couple of slides which talks about the applications of drone in various sectors. So we have talked time and again about these things. Yeah, Jagjit.
Sir, is the drone capable of identifying an object if it is in the path?
Yes, it can detect the obstacles. It can detect, even there are cameras which are attached to the drone. It can detect. Now they have become a smart cameras have been connected to the drones. So drone can really, in fact, there are drones been designed which can identify the person, identify the vehicle, identify the objects. Okay, so all the AI has gone into the drone now. So there is nothing separate that AI alag hai or drone alag hai. So now AI got integrated with the drone also. So autonomous flying is again AI only, as well as using high-end cameras, even your multispectral, hyperspectral cameras, and integrating with AI, you can really find the real-time problems in the field also. Props, like for example, अगर आप military के लिए drone use you can design a drone where your drone can detect the enemy person, enemy tanks or devices, location, everything can use. So it basically you need to train it. That's it. So that is what capability is there in the drones and the camera attached to it.
But
Okay. So talking about the applications of the drones in various sectors, as I said, agriculture is one of the things where we can do for crop health monitoring, soil health assessment. So my topic for the PhD is basically the soil health assessment. Okay. So my drone will be actually designed in a such a way. We are designing a drone in a such a way that if you fly the drone on the soil or on the crop, it will give you the complete status and what is required. If it required to give irrigation, or whether you need to give a fertilizer, or the crop is been damaged by the pest or the other, so you need to give insecticides or pesticides to be, all that information will be given by the drone. Okay, improved resource utilization, so that you can how much you need to spray, all that intelligence information will be coming from this information, like crop health monitoring, soil health assessment, which will give you a better view of your crop, which will help you to minimize the wastage and maximize the yield of your crop. Similarly, you can use for forest and wildlife, for wildlife conservation, managing human wildlife conflicts, forest protection, like fire and all that things. So a lot of time we do not know until unless the fire becomes very big, and then it becomes difficult to manage or control in a short time. So if you are regularly flying drones, we can always see whenever there is a fire or any kind of conflict happening with respect to the human and the wildlife, or you can track the wildlife motions also or movements also and all that things, rather disturbing their things. Urban development, city survey, improved urban planning, project monitoring, project quality assessment, all that things you can do using this kind of development also. Even in healthcare, we have seen, like today morning only I saw a video on LinkedIn where there was some drone was developed for delivering the blood samples or the blood s- supplies to the hospitals from the blood banks. Okay, So rather you taking going to the blood bank, carrying that blood bottles and then delivering it to hospital, you can always configure something that from blood bank it will go to the respective hospital, and then hospital can pick up those bottles or those packets of the bloods for quicker deliveries and quicker activities. Traffic management, road surface condition monitoring. This is very much important, required for Mumbai kind of location where we always encountered potholes and all the things. So last year also there was some survey done by the MBMC or BMC locations where they have flown the drones and captured the footages in real time, and then the contracts were given to the OEMs for filling those potholes, or vendors for filling those potholes. Improved traffic monitoring also, traffic feedback. You can, all these things you can do using drones. Homeland security, we talked about real time surveillance, security planning, drug narcotics detection. So in like Gujarat, Rajasthan, Punjab border, lot of, yesterday only I saw that Punjab police has already, in fact they have approached us also for training their police. So they have formed a team of 10 people. They have taken 10 people and they want us to train those people. So we are in talk with Punjab police for training their personals for flying the drones. Okay. So homeland security, disaster management. Whenever there is a disaster, like it could be fire, flood, cyclone, in that scenario we can always do real time surveillance, search and rescue missions. We can do delivery of essential goods. We have seen this of application during pandemic or COVID times. Okay, in mining areas we have seen enormous use of drones. So mines are people who are used. I mean, there is a guidelines been set up now. Even Indian Bureau of Mines have already set up the guidelines for using the drones for mining areas. Okay, mining, scouting, managing encroachment, contract more monitoring, and all that things. Supply, stock monitoring, all that things are being done now using drones. So there are enormous applications. You just have to think and apply and use it. Okay, the more and more you start using it, it will definitely give you the benefit. Like I will tell you, in 2023 I started working on a project on power line towers monitoring. Okay, it was initially a project for 100 towers only. Actual project was about 16,000 kilometers of power lines. So where we are talking about 12,000 towers. So we were awarded an initial contract of only 100 towers as a POC. So that POC was done in 6 months period. Okay. But whatever the learning, what we have done, the way we have developed the project in itself was very encouraging and motivational for us. So initially we were not knowing how to fly the drone near the power line towers. So during the POC of all the things, it was a very, very great learning experience for it. Okay, we had encountered a lot of challenges with respect to the drone, with respect to the power line towers, with respect to the people, all that thing. So it was a very great experience for us for learning how to imply or how to design a particular solution for it. So earlier, before drones, the power boards were doing manual surveillance of their power line towers. So person used, there was, and it used to take for one particular towers. Let's say I want to survey 10 towers. So क्या करते थे? There was to set of 4 people. So 4 people and a driver in a sumo or a jeep. They used to go to the location carrying DSLR and binoculars. तो वो बंदे लोग जाते थे, they used to go to that location, go near the tower using DSLR. From the ground they used to take the photographs. Okay, so the photographs were not clear. They used to use high-end zoom lenses and all that things. They tried to do it, but still that was not giving the quality what we got using drones. And the timeline. So एक बड़ा टीम, 4 लोगों का टीम, 4-5 लोगों का टीम goes for a week's period of time, and they were only able to do 10-20 towers, whereas in a week I am able to do at least 25 towers. Okay, every day even I was able to complete 10 towers. In 5 days I was able to complete 50 towers. See the efficiency. Every tower, when I am flying a drone, I was able to get at least 300 to 500 photographs with the proper angles, with the proper close up, with proper zooms, all that options. Plus, I used to get the 360-degree view of the entire tower. Okay, so I can do, even as Javjit told or Jaishil told, whether you can do a real time monitoring of those towers also. So my team sitting in backend in the power board offices, they can see the footage of the real time drone flying and capturing, as well as providing the footage to the backend team to see. So they used to talk on the walkie talkie or the on the phone and say, okay, you probably take the more closer, more zoom up option of the particular tower and give me the real time image or real time footage of that particular tower and all, or the component of that of the. A lot of time, those insulators were broken, or the wires, the power on the wires which are gone, they have got get oxidized, or carbon is getting generated because of the sparks what it creates, or moisture and all that thing. So all those challenges are there, and there was lot of reactive happening was there because of the flying of the drone and capturing the footage. Board was able to do lot of proactive maintenance of the things, and that's how they were able to reduce the outages and the revenue loss also. So they were able to gain lot of benefit by using drones for power line tower monitoring kind of thing. Same was done by the Reliance for their telecom towers. Okay, the 5G, 4G towers are there. It's a very complex towers are there and very difficult for physically for man to go on tower and check each and every component, each and everything. So it is very easy for to fly a drone and utilize the concept of drone to monitor and do the reactive, rather reactive, a proactive monitoring and proactive what we say servicing of those towers. Okay. So aerial photography, videography include fields, ad making, special event, journalism, real estate surveillance monitoring. So we have seen there is a lot of boom been happening in the real estate environment where drones have been very very effectively used. Okay. Then commercial inspection as so bridges, cell, TV towers, power line towers, aircraft, railways, wind turbines, mines, oil and gas pipelines, solar panels. So all these things you can consider as a commercial inspection services. Survey and mapping services. Now government is making mandatory that whatever the manual surveys earlier was happening, now all the surveys will happen using drones. Okay, so there are a lot of companies which are giving this kind of services also. So JJ Technologies can think about these aspects like commercial inspection services, survey and mapping services, or also like Zomato, Swiggy. They have already started using drones for their logistics operations. So like delivering the parcel, delivering the supplies, even what is that called, big basket and all those. They are already tying up with some drone vendors for doing the deliveries and all. So like Australia Post, Amazon, they have already started drone deliveries using drones. Medical supplies, organ transplant, relief operations. These are also conducted using drones. Okay, first responders also. Residential home inspection, big buildings. You want to survey the buildings, the structure from the outside. All that things can be done using the drones, like roofs, chimneys, slidings, bricks, and other structures. Exterior damage inspections. Even this is also one of the good, because right now Mumbai is getting transformed from small buildings like 3 floors, 5 floors, 10 floors. Now we are talking about 15 floors, 20 floors, 30 floors, 35, 45 floors kind of thing. So in that scenario, it is not physically possible for human to climb those towers and do the inspection. So drone will come into the picture. A drone will be very very useful in this segment also. Okay, as you see the drone industry grows and thing, definitely you need lot of ecosystem to provide the parts, repairing of the drones, all that thing. So you can think of opening a shop for maintenance or repair of drones, spare parts procurements and mapping. Like you saw initially computers or mobiles, now you see every corner you will see computer shop or mobile shop. Similarly you will see in future either the same computer shop, mobile shop will also have drone parts and drone repairing components, or there could be a separate shops only specific for drone parts and repairing also. Then we talk about aerobatics shows, like drones are being very much utilized in aerobatics. So enter events like drone racing or organize your own competitions. Lot of IITs or universities are conducting such kind of, because they have their own team and they invite other colleges also to participate in those team, like IIT Mumbai. We see every year IIT Mumbai can't does all those kind of activities. Something I spoke about the drone soccer also. Indian government has introduced drone soccer competition. Last year it was held. I think this year it's also going to be held in some time now. Okay. Then aerial advertisement, fly a banner for businesses, or you can use Swan technology also nowadays to do a night display of the drones using multiple drones at the same time. So that is called as the Swan technology. So those are small drones with the lights. So every drone is a pixel kind of thing. So you can create really a real-time images in the sky. Okay, it's a very interesting and encouraging to see those kind of advertisement by the drone shows. Okay, then data analytics, you capture the images, you capture the videos, you capture different types of data. You can always set up a company where you can take the footages from the drone and you can provide the analytics services for the people. Okay, engineering consultancy, where we can give drone identification, procurement, operation solution. So you can become like an aggregator or integrator, right? You have those companies like tech data or rolta, or we have companies like in computers like team computers, or tech I forgot the name, Aztec Infotech. These are the companies which provide the services. Then you have SaaS based firm. You can always have something like we talk about UTM, or we talk about the vertiport system setup. So all this can, or even agriculture, SaaS based services. So use drone as a service now they have been providing. So that also kind of thing you can do. Then insurance companies are also has geared up. They are providing now insurance for the drones also. So the more and more drone comes into the market, you will have a lot of insurance policy coming up for your selling of the insurance policy to the people. Okay. So with that, we complete the major topic of rotorcraft operations and aerodynamics. Okay. So let's quickly continue with the topic of hybrid, because that's just a